Let's now look at another hypothesis testing problem concerning the braking distances of cars. We have on the screen the various braking distances of the Mercury Sable after they've been equipped with new tires. Does this indicate that the new tires have indeed decreased the braking distance? And we'll use alpha equal to 0.05. To get started on this problem, we realize that we have the null hypothesis is that the mean remains 159 feet. In other words, we've got these new tires, but we'll play devil's advocate and say whatever changes occur are simply because of chance as opposed to the effectiveness of the new tires. The alternative hypothesis, on the other hand, will be that the braking distance has decreased. We feel that the tires have worked, and so therefore they work better than the old tires, and so we think that the braking distance has indeed decreased. We set up our z statistic, and our z statistic will be equal to the sample mean minus the population mean under the null hypothesis divided by sigma over square root of n. Now in this problem, the population standard deviation sigma is not known, so I will use the estimate x bar minus mu over s over square root of n. And because I have a decently large sample, I think that this is a decent approximation to make. And so I will just simply replace sigma by the bootstrap estimation of the sample standard deviation. Okay, now let's work out what those numbers are. Average of the 45 tests is 154.1, and the sample standard deviation of these tests is 19.94. Get a couple more displaces, 19.9405. Okay, so using those numbers, we have that this is equal to 154.1, that is our sample average, minus the population average under the null hypothesis, which is 159, divided by the sample standard deviation of 19.9405, divided by the square root of n, which is square root of 45. And assuming the null hypothesis is correct, we know that this test statistic will follow a normal distribution. And so doing the arithmetic, we get our z value to be equal to 154.1, so a 7 here, minus 159 divided by c7 over the square root of 45. So we get a z value of negative 1.66037. Okay, and the next step is to figure out the critical value. To find the critical value, we have the bell curve. And we need to find the mark so that, in this case, 5% of the area lies to the left. And we have a left tail test in this problem because the alternative hypothesis has a less than sign up here. Okay, so we use Excel to figure out the critical value, Z critical. So norm S inv of 0.05, which works out to be negative 1.64485. And so that determines the cutoff between when we reject and retain the null hypothesis. On the left is where we reject the null hypothesis, that I think it is more believable that the null hypothesis is false than to get a test statistic so large. On the other side, we retain the null hypothesis. Or fail to reject, so that I think that the test statistic is not so extraordinary to believe that the null hypothesis is false. In this case, it is indeed slightly below the cutoff, and so our decision is, in words, that we reject the null hypothesis. It appears that the braking distance has decreased with the new tires. These are the ones that in real life give statisticians fits, that the z-value is so incredibly close to the cutoff, but that is the decision that we make with the available data.